What is mean by network? Network is basically a simple definition of network is collection of devices connected each other with the help of some kind of media. So these are three parts inside the network definition. Multiple computers or multiple computers connected each other with the help of media. Media means cables, which we already understood: twisted pair cable, fiber optic, coaxial cable. And the third component is with the help of networking devices. So these three components made network possible. Communication devices will be connecting with the cables or media, and there will be some intermediary devices, switches and routers. If we know these three things, we can combine three things together that will form a network. For example, we are having 10 computers, we want to build an app, so we will be requiring cables, twisted pair cables, that is the second part. And then these all computers should be connected to some central point like switch or router or whatever the device is. So we have to make network with these three components: computers, cables and networking devices. So all the networking course is rounding around these three things. Every time we will be understanding how computer will be communicating, how IP addresses we will be giving, how it will be connecting with the NIC to the cables, and then how switch will be dealing with the computers. And if we want to go outside, how router will involve and we will go out. So what is network? Basically is interconnecting devices such as computers, servers, smartphones and other hardware which communicate and share resources like data, files, printers. So what is the basic purpose of building this network? The basic purpose of building this network to share devices each other, to share data each other, to share printers each other, to share facilities each other. So one is common example at home. If you are having at home one computer and one printer, so you have connected your printer with your laptop and you are doing printing. But after some time your brother got one laptop or one computer. He also want to print. So what you will do? You will remove the printer and give it to him and he will or she will print. But the problem is if in office 10 computers are there and one printer is there, so what will happen? Every time you need to remove the printer and give it to others? No, it is not possible. So what we will do? We will take a simple switch. We will take media cables, 10 cables, and we will connect all to one switch. And then we will remove the single computer printer and we will connect directly to the switch. So that will become from local printer to network printer because the printer will be same. But now we are connecting it to directly switch. So that switch will be making possible that everyone can directly send print command. That will be network printer. Same in here in the diagram. If I will connect, for example, in this diagram, that is my desktop computer at home. If I will connect printer here directly, that will only provide printing to me. But I didn't connect printer here. I have at home laptop also. I have some gaming computer. I have mobile devices and I have Wi-Fi router which is providing Wi-Fi to these all. So these all computers now take print from this computer, this printer, because this printer is now connected to central switch. And also this router is connecting to its outside firewall and there is some modem and then we are going to the internet. So this is basically an internet. So this is the basic layout of the network. First, we need to connect all our home appliances to central switch, and this central switch will be connecting also printer. So printer basically sharing resources with all people now. Before it was connected to directly one computer. So now we can share resources, share printing too. For example, I have one hard disk also, external hard disk, in which I have too much movies or data or whatever. I want to share it with other people, but I have to disconnect this hard disk and I give it to one by one all, then they can. But what I will do, I will just connect this hard disk to the switch and I will give one IP to that hard disk, and that hard disk will be available over the internet. Everyone can just get by IP and they can copy the data, whatever 10 PCs, 20 PCs, 30 PCs. So we can share the resources also, we can share the devices also. And even if I am having only one internet connection here, basically this one, that connection is not working from outside. So I am connecting my mobile data with my laptop. No one else will be getting internet, but I am connecting my laptop with my mobile data. So I can share my mobile data over the internet also. I will just share my computer and they can use my data. So that will also possible. So we can share connection, we can share devices, we can share resources, we can share everything with the help of network. If there is no network, then that is very difficult. So that is the basic purpose of network, that to share resources, share devices, share internet connection, share files and everything we can. Now it becomes to building the network. How we can build this network? For example, there are multiple types of network. First network is local area network, LAN. What is local area network? It is in a limited area such as home, office or building. Why limited area? Because if I am connecting some computer to that switch, how many computer I can connect which is available, the ports of the switch. For example, switch is having 10 ports, then only 10 computers I can connect. Even not 10, because one port will be connecting to printer, one port will be connecting to the router, and two ports will be saved. So in 10 ports which I can only connect 8 computers. So that is only limited to some area. So that is why we are calling it LAN, local area network. Local mean which is something inside somewhere, not outside. After that, if I want to go outside from the inside network, I need to use router, because switches will not take us to outside the world. Same in the diagram, if I am connecting a switch here, that will not directly connect to the internet connection. There will be some router involved. That router is basically work on IP addresses and will take us outside the world. Switch will not take us outside the world. So we must need one router. That router will take us outside the world. Same like here in the diagram, I have one router. Same like at home, if I am connecting 4 or 5 computers with one simple switch, and that simple switch is connected to Etisalat router will take us outside the world. So whenever we will be moving from switch to router, that will become WAN, wide area network. That is covering broader geographical area, like often connecting multiple WANs across cities, states and countries. Because I am connecting to one router, and that router is connected to Etisalat, and Etisalat is connected to worldwide cities and whole UAE. So that will take us outside the world, outside the UAE, outside the other, and the outside router of UAEs will be connecting to other countries also. So that will take us unlimited outside, wherever you want to go. So whenever the boundary of switch ends and the boundary of router starts, whenever our data moves outside the router, WAN starts. So WAN have no limit. Whenever you have routers and routers and routers wherever you want to go in the world, because all routers will be connecting each other. So LAN have a limited geographical area, but WAN have no limit. When whatever you want to take, whatever countries or borders or even satellite, you can take it to the, so that will be considered WAN. So WAN is having a very huge geographical area, border area. After that, wireless LAN. What is mean by wireless LAN? That is simple LAN, but we are not using cables here. We are using Wi-Fi connection. For example, we want to connect computers now in a lab, but we don't have cables. So we have wireless NICs inside computers or laptops. We don't have wire connection. So that will be making LAN, but that will not called LAN, because local area is building with the cables. Wireless LAN is building with the Wi-Fi. So we will be using wireless network interface card, and we will be connecting to central device. That central device will called access point, not switch. Yeah. Wireless NIC card will be there. Like same laptop have wireless NIC card. We can connect it to Wi-Fi. So that is wireless NIC card. In LAN, computers have local area network and wired NIC card, which we can connect cable. But in usually mobile devices, we don't have wireless NIC. We have, but we don't use it. We use Wi-Fi. Both have connection inside. So whenever we need to connect Wi-Fi computers with Wi-Fi, we cannot connect it to switch, because switch can carry only traffic from cables. So we need another type of device which is called access point. So in wireless LAN, two things are different. One, wireless NIC and wireless media, which will be connecting through air. And then the device will not be switched. That will called access point. So that will make from LAN to wireless LAN. So two things will be different. One, NIC will be wireless NIC, and the cable will not be there, Wi-Fi only connection, and that Wi-Fi connection will be coming from not switch, access point. So there will be access point and wireless NIC card, which will make possible. So concept is same, that in LAN we are using switch, cable, and physical NIC with the connection. But in wireless LAN we are connecting wireless network card without media, and we are using access point. So that will become the Wi-Fi technology. After that, if we are connecting some limited geographical area network also, but that is not only limited to one building. If this is limited to some cities or some bigger areas, then yeah, but we already said that WAN don't have boundaries. But if we make WAN some boundaries, like this WAN is only for UAE, for all 7 states, that will not called WAN. We can give another name, MAN, metropolitan area, because WAN have no boundaries. Whenever we want to go outside to countries, and maybe cable is going from sea and mountains and going wherever you want to take it, WAN have no boundary. But when we decide that this WAN is having little boundaries, like UAE network only, it is not going outside the UAE, that will not call WAN. We can say that this is a metropolitan area that is connecting only 7 states of UAE, so that will be called metropolitan area. So that is covering some city type of area. That because just generally we can divide some kind of boundary of the WAN. So that will be called metropolitan. Basically, MAN is a middle network of LAN and WAN. LAN is very limited geographical area. MAN is somehow we can make boundaries of WAN, and the WAN is unlimited. So we can say that MAN is a middle network of LAN and WAN. So in between something where we can define the boundary of WAN. So that covers over a large areas, that cover a large area than LAN but smaller than WAN. See, the definition is saying cover more area than LAN but less area than WAN. So that we can call WAN. After that, virtual private network, VPN, that is the same network like WAN, but that is protected. Protected how? Our computer is taking our data to router, and router giving data to Etisalat. Now outside the world, hundreds of routers there, anyone can sniff our data and hack our data. We don't want to send data plain text over the internet, because I am sending one email to my boss in US, and in this email I am sending one passcode of ATM or something like some code of business code that someone will hack inside the network. Over the internet, hackers are there. They can use my business information and they can hack my account. So I want to secure my data going from outside the world. So what I will do, I will take one specific service from the ISP. ISP mean Etisalat, that I want to hide my data somewhere, like inside the pipe. My data will go on your cables, but my data should be hide, or my data should be encrypted. If someone will sniff that, he will not understand. So that is called VPN, virtual private network. The data will be going on the same Etisalat links, router to router, but my data they will encrypt. What they will do? They will do some encryption algorithm. My data is ABC, but over the net it will be going XYZ. So if someone will sniff that, XYZ will be no use, because actually my data is ABC. They have just used some algorithm and they have changed my data. That is called encryption. So if you apply encryption on your data, it is going on the same, but it is looking like it is going on a separate pipe. So that is called virtual private network. Whenever we use hiding our data or we use encryption algorithm, that will be going over the public internet, but that will be secure data. So that is also kind of WAN, but that WAN is secure WAN. So if you call secure WAN, that will be called VPN, virtual private network. See, extend a private network across a public network. For example, from our private network, something is going on the public network. Over the internet is public network, but anyone can sniff our data. But if we will be using VPN technology, because for VPN we need to pay to the ISP. For example, ISP is saying we cannot hide your data because our router will encrypt, and we need to use technology. For that technology, you need to pay extra amount. So we will be paying some extra amount to the ISP, and they will be applying the algorithm, and our data will be going securely. No one can sniff. If someone will sniff it, they will not understand it. So that will be putting some security over private network to public network. So that is called VPN, which is making our private network as secure over the public internet. Last one is very easy, PAN, personal area network, which you make at home. Like simply, if you have a network in your laptop and then you want to share it with your friends or with your family, whenever you have a party at home and some friends are coming at home, so you are sharing your Wi-Fi with your friends that is inside some type of home, and you have control over that. You can manage that Wi-Fi router, so that is called private area network. A small network typically within a range of person, such as Bluetooth connection or smartphones and one sheet, like that. Simple computers inside your home appliances. You have connected your home appliances, TV or something with the router also, and some of your friends are coming. You are sharing password with them, or you are using Bluetooth technology at home for TV. So these all inside your control will call personal area network. So that is basically 5 6 categories of the network. One is limited geographical area network, LAN. One is unlimited area, WAN, and in between these two is MAN, metropolitan area network. And if you are connecting LAN with the help of Wi-Fi connection, that will be called wireless LAN. And if you are encrypting your data over the WAN for the public use, that will be called VPN. And if you are connecting some of the home appliances, that will be called PAN, personal area network. Okay, now we have made different kind of networks, whether it is a PAN or whether it is a HAN or whether it's a VPN or LAN, WAN, wireless LAN. They have to connect some devices and they will be going outside the network. But they will go in step by step. First, data will go from your computer to cable, and then from cable to switch, and then from switch to router, and then from switch to router to firewall, and firewall will be connecting to the internet. So how data will be going step by step? If you want to understand the communication of the network, then we have to understand these models, understanding the OSI model. What is OSI model? OSI model is a general model which people make that to understand the communication. How to understand the communication, how it is happening step by step. So we will start from number one, top, bottom to top. OSI model will always go from bottom to top. So we need to understand the layers 1, 2, 3, 4, 5, 6, and 7 layers. Why we are dividing these tasks into layers? Because whenever you start some understanding something, you need to divide it into tasks. For example, if you want to communicate with me, but you don't know Urdu, I don't know Hindi, so we need a common language. So to understand a common language like English, we need to understand English first. So whenever we start understanding English, English is a very big language, so we need to divide it into tenses. So if we start learning tenses, then we need to divide these tenses into further categories. Like one tense is having 4 further categories. So like this, we have to start understanding communication of the network. Then communication of the network is also a huge communication network, like one-to-one devices all over the world. So if we start understanding networks, then we have to divide the tasks into parts. That parts is called layers. So first layer will be physical layer. What is mean by physical? Anything which we can touch, that is physical. So we start connecting computer with the cable physically here. So that is called physical layer, in which we deal with the bit streams over physical media, deals with the hardware, and here we will be dealing with the bits, because we give data to computers in the form of ABC, because computer don't understand ABC, they understand 0 1 language. So they will convert it into bits, 0 1, because computer only understands 0 1. So that physical layer will be dealing with the bits, because that is still inside our computer. Now we will connect it to cable. That when we will connect it to cable, the second layer will come, data link layer, because the word is data link. So we are connecting our data to link, means we are connecting our bits to some cable. So that is called data link. We are linking our data to some cable. So now our bits will jump from NIC to cable. So how cable will be managing data? Physical addressing and error detection will be happening here. What is mean by physical addressing? Physical addressing means when we are leaving our data from one computer to over the world, then this data should be identified. Whose data is this? For example, 10 computers are connected to one switch. So how we will identify this is my data and this is your data, this is someone else's data. So we put some address on that. For example, it's my computer is sending data over the cable because it will go to the switch. Your data will also go to the switch. So how we will identify it's your data or say my data? There should be some numbers or some address over there. So every NIC have a specific address over the NIC already written on the NIC, which is called MAC address. So MAC address will be identifying that this is my data because MAC address are unique all over the world. All over the world, every device when manufacturers are making, they have to buy the MAC address from some company. So that company will provide the MAC addresses. That is why all over the world, every device have a different MAC address. So I am sending my traffic bits to the link. So I should be identify these are my bits and you will be sending your bits. So my MAC address will be written on that data. That is called physical addressing. So I will write my MAC address on the bits which are going on the cable and then it will be identified that are my bits. You will be putting your MAC address and it will be identified these are your bits. So physical addressing mean we make some packets of the bits because bits are like streams, long streams. So computers before sending to cable they make it chunks of bits. 10 bits, 10 bits, 20 bits, 20 bits, 20 bits, and every bits they will put MAC address like packaging because we need to send more data, more bits. So we have to divide. That is called frame. That chunk of data is called frame. Frame means whenever we are sending bits to the link, we have to divide in chunks. So these small chunks will called frames. So on that frame, we will make a package type frame and then we will put our MAC address. That frame is my frame. The second frame is my frame. Third frame is my frame. For example, I have made 10 frames and all the frames I will put my MAC address. That is called physical addressing. That will be identified to the switch. These 10 packets or frames coming from user 1 and the other 10 packets coming from user 2 and then the rest of them. After that, it will go to the these frames will go to the switch and switch will be dealing with these MAC addresses. Okay, after that, if we want to go outside the switch, then router will involve and the router will be sending data as a packet. So this frame will become packet. This frame will become packet. How we are dealing with the frames to packet? Because that will be the same bits inside which we send already in the frame 10. But routers don't understand MAC addresses. Router understand IP addresses. There are two addresses. One is physical address, MAC address. One is logical address, which is used by the router. So that IP address we need to put it also on the packet. So that is why we are now calling frame to packet and then that is called logical addressing. So two types of addressing. One, when the bits leaving from here, we divide it into segments and then we call them frames and over the frame we put it MAC addresses. So after that when it goes to the router are putting IP addresses on the frames, it will become packets. So that packets addressing is called logical addressing and that will be used for the routing data. Routing means router will move data to router, that is called routing. Routing means whenever router will take data because there will be multiple routers, so router will be dealing each other with the packets and that is called routing process. So routing and logical addressing is happening on the third layer which is called network layer because that will be involved network. Okay, now data is reached to the network router and after router now we need to put some security, who is coming inside, who is going outside. So packet will go to the firewalls and IPS security devices. Then now we will call packet to segment. Why it is called segment? Because another layer is involved here, data reliability and flow control. Flow control mean now we are dealing how much data can leave and how much data can come and who is allowed to go outside, who is denied from outside. That is be handled by the security firewalls. So now data is in transport. Transport mean data is traveling from network to network to network. So that transport layer is making data reliable or unreliable, and that is helpful with the help of flow control. After that, one session will be maintained. Why we are maintaining session? Because we are sending some kind of packets from one computer. You are also sending, third computer is also sending. So hundreds of packets going to the switch, and that switch is need to send it to the outside the world. But who is the destination? Who knows how many packets coming? So there should be session maintained between before sending data. Like this session layer is maintaining and connection applications, handle the session, and establish and maintain the session. Why we are establishing session? Because we want to send some data, and the other one should know how much data is coming and how much time will take the session. For example, if I want to call you, the call, when I will drop the call, then our communication will finish. So we need to establish one session. When I need to call you, I need to dial some number. What is this? I am creating a session between you and me. I am checking if the line is clear, you are not busy, or your phone is free. So that is called session. So first we will build a session, then we will be talking 10 minute, 5 minute, 20 minute. After that we will break the session. So network communication also make one session before sending traffic, and in between session they will tell the other people how much data will come, how much time it will be becoming session, and how will data finish, and then we will break out the session. Okay. With sessions, another layer is working, that is called presentation. Basically these three layers work together at the same time, but we just divide it into understand, but they are working together. For example, when transport is happening from one place to another place, session is maintaining session, and this layer is doing something else, like between the application layer, translation, and it handles the encryption and compression and translation. These three tasks also ongoing with the help of session. What they are doing, encryption, which I already told you, if I'm encrypting my data, that someone cannot sniff it. And if the data is heavy, but devices want to send it to other, that they are making it little compressed. So they are removing some unnecessary data, and they are, for example, my data is 1 GB, but communication is heavy. So routers will remove extra bits. They will make it 500, 600 MB, and they will send it. And they will tell during the session that this data is actually 1 GB. You need to add that bits back, and then data will be lower, but whenever will reach to you, you need to add this bits again, so it will become again 1 GB. So networks do like this. For example, I want to send 1 GB file, actual data is inside 500 or 600 MB, the rest of the data is only to identify things. So routers will remove that extra data, and they will send information by session that this data is coming to you. Whenever this data will reach out to you, add again these extra bits from your side. So that will be lower on the internet, but when it will reach to the destination, it will become again 1 GB. So that process is called compression. So they will compress and they will encrypt the data. But to do these tasks, another layer is responsible, which is called presentation layer. So when transport is happening, session also maintaining, and these translations and encryptions also happening. So that is why these three layers work together. But we have divided just to understand separate concept. One is making data flow control, one is making session, and the third one is making presentation and encryption and compression and these kind of tasks. After that, data will reach out to destination and the application will be receiving it. Because when I send data, I have used some application. For example, my data is web, so I am using web browser, I am using HTTP. So next receiving should be a HTTP application. So when it will reach out there, some application will receive it. So application, everything is directly connected to application, handle the high level protocols, data formatting, and user services. All this is happen with the help of some application. So whenever we need to deal with application last, so we have another layer, application layer. For example, now if I start from here to understand easily, first there will be bits inside computer. That bits will go to switch. Switch will make them frame. What is frame? They will put the MAC address over that. and they will be dividing this tree into small frames, and over the frame they will put it physical address like MAC address. After that they will give this frame to router, and the router will make it packet. What is called packet? They will put IP addresses on that, because they have to understand all over the network with the help of IP, not MAC. MAC only work inside switches. So switch router will work only on IP addresses. So they will put IP addresses on that. That will be called logical addressing. Before it was physical addressing. After that, they will give it to firewalls or outside the segments. They will call segment, because they will put information of reliability, unreliability, and flow control information. After that, these are not any bits here, but data will be handled by three layers: transport, session, and presentation together. Transport will be making data possible to go outside small chunks, and session will be maintaining a session, and presentation will be making encryption and compression and all that. After that, it will be handled to the some application. So data will reach out to the other side. Now, when data will be coming back, again this process will happen. First, application will give it data to presentation, and then it will come back like that, and it will be coming like that. Again, physical layer from there, and then data link layer, network layer, and data will be coming back in this fashion. So that is the model which we use to understand the communication, how communication is happening. Now we can easily say that first we make bits, then it goes to media, then it goes to switches, switches make them frames, physical addressing, and then it gives to router, router make packets, packets they have IP addresses, logical addressing, then they give it to security firewalls, they will put some reliability on flow control, and at the same time one session will be maintained, and the presentation will be making encryption or something like that. After that, data will move on, and then it will reach out to some application, and then it will reverse process again, and it will come back. Now we know each and every step of the network. Okay, if we want to remember these layers, again same numbers 1 2 3 4 5, because sometimes we forget which layer was first layer, which was layer was second. So we can use this word: please do not throw sausage pizza away. So this is a general English sentence by which we can just memorize the layer numbers. For example, P, first P mean physical layer, D mean data link layer, T mean net transport layer, and S mean session layer, P mean again presentation, and last A mean application. So we can memorize with this sentence easily. You understand? Because these layers are fixed. You cannot interchange each other, because that are going one by one process, which we already understood. First, if we cannot say that first packet will come and then frame, no. Before frame, then packet. So we need to remember these layers one by one. So if we will jump in between layers, we will forget the layout of the network. So we need to memorize 1, 2, 3, 4, 5, 6, 7. So that is the sentence which will help you to memorize this. Please do not throw sausage pizza away. This is general sentence when we bring some pizza at home, but child came, he put more sausage on the pizza, and your wife said, no, throw it outside. So I am saying, no, don't throw it outside. Just remove the sausage and eat. Why we are wasting money? So that is a simple sentence we use every day at home. But that sentence is very powerful to memorize all the layers. Please do not throw sausage pizza away means presentation, physical data link layer, network, transport, session. Just we use first character, and then we. Now there is a detailed summary of each layer, which we can understand also. What is the purpose of first layer? To provide the services, because we are understanding at application layer all the applications and all the services. Presentation layer, what are the basic purpose of this? Translate the data, encrypt the data, and compress the data. We already understood. Session layer is establishing and maintaining and terminating the connection between multiple points. Transport layer is responsible for data transfer and message flow control and error recovery. After that, network layer, it handles logical addressing, and they are making routing packets. Data link layer, we already understood that error correction and manage physical addressing like MAC addressing and network segmentation. Physical layer is responsible with the physical transmission of data over the hardware, like bits and all that. So we can just understand one by one all the layers working.